Welcome to the Bosch Virtual Driving Center. Here we use computer simulations of a wide range of driving situations to continually advance automotive technology. Today we'll show you what Bosch is doing to get the most torque out of gasoline direct injection engines. An exhaust gas turbocharger helps to improve engine performance and increase torque. The exhaust flow determines its degree of effectiveness. Let's take a look at the practical application in a driving simulation on board a car with exhaust gas turbocharging. A typical situation. You're on the freeway moving towards a large truck ahead. Because the left-hand passing lane is blocked, you take your foot off the gas and let your car coast. Then, when the passing lane is clear, you accelerate and feel the turbo lag. In driving situations such as this, the engine produces only a weak exhaust flow. Driven by a turbo in the exhaust tract, the turbocharger can produce only minimal boost in the intake tract, resulting in a weaker cylinder charge. When you then need to accelerate strongly, the turbocharger takes some time to spin up to its full performance level. And only then, based on the higher charge air pressure, is a noticeable increase in torque possible. This delayed response is known as turbo lag. Let's take a look right into the interior of a cylinder to see what causes the weak flow at low engine speeds. Before the turbocharger has reached its full performance level, only minimal air pressure is present in the induction tract. Also, during the induction phase, when fresh air enters the combustion chamber, some hot exhaust gas from the last combustion still remains. The engine receives too little air to attain the highest torque performance. Thanks to DI Motronic from Bosch, the whole process can be greatly improved. At Bosch, we've developed a solution especially for low torque situations to push more fresh air into the cylinder. It's called scavenging. This procedure uses the synergies between direct gasoline injection with DI Motronic, turbocharging, and variable valve control. DI Motronic regulates timing of gasoline intake and exhaust valve functions and controls the turbocharger with its wastegate or bypass valve. In the low torque range, scavenging does the following. Camshaft timing control causes the intake and exhaust valves to remain open for a moment simultaneously. The processes of exhaust discharge and fresh air intake overlap. The pressure in the exhaust tract is lower than in the intake tract, causing a draft. Cold incoming fresh air flows into the cylinder, rinsing out most of the remaining hot exhaust gas. This not only results in better engine cooling, but also allows for a higher level of fresh air charge in the cylinder. This rinsing procedure is made possible by DI Motronic, which by employing direct injection only after closure of the exhaust valve, prevents fuel from spilling into the exhaust tract. The modified intake and exhaust valve timing results in the intake valve closing earlier in the intake stroke, preventing a reverse flow of the fresh air already inducted. Thus, more fresh air remains available for mixture formation in the cylinder. The increased cylinder charge improves 1. The spontaneous engine torque, and 2. Leads to a stronger exhaust flow and in turn higher turbo RPM. This increases the charge air pressure to levels similar to those previously reached only with higher engine torque. Thus, a further benefit to charge and torque performance is created. The combined effect of these functions, in comparison with a turbocharged port fuel-injected engine, is a significantly more dynamic torque buildup and a 50% higher stationary torque at lower engine speed. The effect of scavenging can be clearly felt. The sporty engine response gives you the powerful feeling of a much larger displacement engine. The benefits of DI Motronic scavenging technology: reduced fuel consumption in the low torque range, which results in lower CO2 output, a sporty engine response, and thus unhurried, relaxed driving.
Bosch. Invented for life.
Welcome to the Bosch Virtual Driving Center. Here we use computer simulations of various driving situations to continually develop automotive technology. Today I'll introduce you to the business division Gasoline Systems. At the heart of our work is the generation of engine power and the transfer of power via the transmission to the wheels. Our know-how encompasses the entire drivetrain of an automobile. That includes the fuel supply, intake air management, the fuel injection and ignition. In addition, the whole of engine management, transmission control, and finally, exhaust gas aftertreatment. Gasoline systems expertise can be applied to gasoline engines with manifold or direct fuel injection, as well as to flex fuel and electrified engines. Our engineers work together with automobile manufacturers to develop solutions for new performance standards and technology. We apply our systems in the vehicle, developing them through to serial production. So let's have a look and see just where in a vehicle our know-how can be found. Let's use a gasoline direct fuel injection model to follow the path the fuel takes from the tank to ignition. The in-tank unit is a modular system that delivers the fuel from the tank to the high-pressure engine pump. It requires only minor modifications to be adapted to any vehicle. Now let's take a closer look. Our fuel filters allow no particles larger than 5/1000th of a millimeter to pass. Not even a strand of my hair would get through. Unless, of course, I modify myself. Within the system, the high-pressure pump increases the delivery pressure created by the tank unit many times over, raising it in some cases to 20 megapascal or 200 bar, and that means serious power. The fuel rail distributes the fuel to the high-pressure injection valves. These injectors with multi-orifice technology enable high precision, the tiniest fuel droplets, and a variable spray configuration for optimal combustion to be achieved. But in addition to fuel, an engine also needs air for combustion. With our products, we offer comprehensive intake air management. Let's take a detailed look at the individual components. You'll find our throttle device here at the entrance to the manifold. To reduce the smallest adjustable airflow setting still further, we've optimized the geometry of the throttle. Whoa, that's a major draft in there. With its special geometry, the manifold influences the charge cycle processes, which give the engine its respective performance characteristics. Let's accompany the air on its way to the combustion chamber. Here we find the swirl control valves. They influence the passage of air into the combustion chamber and create a targeted swirl effect for the best possible combustion. Wow, that's fun! Oh, excuse me. The air supply is a significant determining factor for the quality of combustion. The air mass must correspond to the fuel mass. Its movement must be coordinated with the form of the stream of injected fuel to ensure the ideal spread of the flame front in the combustion chamber. The mixture formation is an important factor for exhaust gas treatment in the catalytic converter. With the help of the lambda sensor, it's regulated to enable the three-way catalytic converter to achieve its maximum treatment performance. Driving pleasure with low emissions. You've just seen systems that make a contribution to economical and clean combustion. They provide the exact dosage, processing, and distribution of air and fuel for each individual combustion cycle, and of course exhaust gas aftertreatment. all of which is regulated by our engine control unit. Let's take a closer look at the unassuming little box. We're here in the computer center, headquarters of engine management. I'll demonstrate its performance capability using the example of direct start, with which a fuel-saving stop-start function can be realized. Our engine control unit, here the DI Motronic, detects when the vehicle has come to a halt and cuts off the engine. A speed sensor constantly measures the crankshaft angle and transmits the data to the control unit. Based on this angle, the DI Motronic discerns the shutoff position of the individual cylinders. It selects the one suitable for the direct start and calculates the actions necessary for the direct start. As soon as the driver wishes to move off, DI Motronic instructs the starter and the fuel injection system. Fuel is injected. Ignition. The engine starts. Turbocharged engines with gasoline direct fuel injection let the DI Motronic show its full performance capability. The interplay of fuel injection, exhaust gas turbocharging, and camshaft timing control or scavenging calls for high-performance engine management. The investment pays off. The once typical disadvantages, such as higher peak consumption and turbo lag, are history. That makes driving a lot more fun. Just generating the power isn't enough. It must also be efficiently distributed to the wheels. In our business unit's continuously variable transmission and transmission control, we develop components, modules, and software to ensure optimal delivery of the power to the roads. Continuously variable transmissions have significant advantages for urban traffic: no gear shifting and coupling, more driving comfort, and lower fuel consumption, thus less CO2 output. Automatic transmissions can be adapted with software to meet a wide variety of demands. Our electronic transmission control recognizes the current gear status, the driving situation and style, and reacts accordingly, for example, with optimized shifting points. And that means more driving dynamics and comfort. Bosch Gasoline Systems helps automobile manufacturers worldwide to further improve the functions of the entire engine system for higher performance, lower emissions, and reduced consumption with correspondingly less CO2 output. We develop our market-driven, customer-specific engine management systems in development centers around the world. Electrified engines will play an increasingly important role in the future. Our engineers have worked successfully for many years on the integration of the combustion engine and the electric drive. Our ambition is to keep on making vehicles better so that you can be a cleaner, more economical driver and more at ease on the road. We achieve this ambition with a comprehensive program for the entire drivetrain, drawing on a wealth of know-how to serve our customers with the greatest competence and individual care. With our services, we help automobile manufacturers to adapt systems individually to their vehicles. Together, we always find the right solution.
Bosch, invented for life.
Welcome to the Bosch Virtual Driving Center. Here we use computer simulations of various driving situations to continually develop automotive technology. The importance of air management is on the rise due to increasingly stringent emissions regulations, because pressing the accelerator pedal not only activates fuel injection, it also engages a complex system of air, exhaust gas, and fuel. In the business unit Air Management, we use a global network to develop, calibrate, and produce a system made up of components that make optimum use of the power of air. Both the design and function of the components are precisely matched to the vehicles used by our international customers. Our products control the following factors: the mass of the intake air, the movement of the air, the mixture of air and fuel, and the correct cylinder charge. Most of our air management components rest on the intake manifold, for example, the electronic throttle device. Its electric drive with positive feedback enables exact control of the intake air mass, taking the current operating status into account. For ETC to work, the electronic throttle device and accelerator pedal module need to communicate with the electronic engine management system. With ETC, the throttle valve position is separate from the accelerator pedal position, which enables various functions. For example, driving dynamic systems can reduce engine torque in risk situations. The throttle device is also used in diesel engines as a control valve. A series of actuators along the air path control the gas streams and influence their dynamics. These actuators include charge motion valves, exhaust gas recirculation valves, and variable turbocharger guide vanes. Conventional actuators are often operated pneumatically, and thus can give only the positions open or closed as feedback. The general-purpose actuator brings fresh air into the engine chamber. This electric actuator renders the flaps and valves infinitely adjustable, with precise position feedback. This means that all the air management functions can be better coordinated. And the result is lower fuel consumption, less CO2 output, and reduced emissions. For example, ideal fuel consumption can be achieved by adjusting the flow speed and the swirl of the intake air. With the general-purpose actuator, the charge motion valves in the intake manifold can be adjusted more precisely so the cylinder charge can better adapt to the operating status. This supports compliance with current and future emissions regulations. There are also benefits from the general-purpose actuator here in the turbocharger. With the electrical activation of the guide vanes, exhaust gas pressure is implemented so that the turbocharger can start at low speeds. The precision of the general-purpose actuator boosts driving comfort by a gentle, early initiation of the turbo effect. Furthermore, the variable turbine geometry helps save fuel and reduce emissions. The trigger for the use of one of our air management components is right here in the tank. A carbon canister absorbs the evaporated fuel to prevent it from being released into the environment. The canister purge valve, TEV, feeds these gases into the intake air, thereby reducing emissions. We supply various types with customer-specific connectors and individually positioned in and outlet. Like all Bosch components, the canister purge valve is characterized by its compact design, lightweight, and of course, its high vibration resistance. For gasoline direct injection with turbochargers and for systems with automatic start-stop mechanisms, we've developed canister purge valves with particularly high flow rates. The precise metering of air also plays an important role in the exhaust gas aftertreatment of gasoline engines. In the case of a cold start, the secondary air pump supplies additional oxygen to ensure the afterburning of the remaining exhaust gas. This ensures a direct reduction of emissions. The heat resulting from the afterburning also brings the catalytic converter to the required high operating temperature more quickly. Driving pleasure starts here, and we mean that literally, because this product from Bosch Air Management is one you can really feel. The robust APM accelerator pedal module sends the driver's precise request for more or less torque to the engine control unit. Designed according to ergonomic principles, it can be adapted, like all Bosch components, without significant effort to all our customers' vehicle types. Composition, mass, speed or velocity of the air intake. Only the harmonious interaction of all the components in the air system yields the best results. With Bosch air management products, engine developers can implement their application strategy more easily and effectively. For the powerful, clean engines of the future.
Bosch, invented for life.
Welcome to the Bosch Virtual Driving Center. Here we use computer simulations of a variety of driving situations to constantly further develop technology for the automobile. Today I'd like to present to you the Bosch systems for hybrid and electric vehicles. The powertrain electrification represents a considerable contribution toward making cars even more economical and environmentally friendly. Over the next 20 years, highly developed internal combustion engines will dominate the automobile market because the constant further development of gasoline and diesel systems during that period will make the biggest and most economical contribution toward the reduction of fuel consumption and CO2 output. But today's hybrid systems already represent the first step in the electrification of the powertrain. Hybrid vehicle technology creates potential for fuel savings and independence from dwindling fossil fuel resources, and CO2 output will also be further reduced. Bosch now already has the technology for drive units that are entirely electric and produce no CO2. Over the next 10 to 20 years, technological progress, the increased marketing of electric vehicles, and an expanding battery charging station infrastructure will see electric vehicles become an economical alternative to internal combustion engines. The hybrid drive unit is a combination of combustion engine and electric motor. In certain driving situations, the electric motor supports the internal combustion engine. Do you hear something? No? I don't either. That's because the hybrid control unit from Bosch has switched the engine off. The vehicle is no longer consuming any fuel. Let's take a closer look at that process. A hybrid electric vehicle combines an internal combustion engine and an electric motor in a single propulsion concept. This is the electric motor. It has two functions. As a motor, it drives the vehicle electrically. As a generator, it produces electrical energy and charges the battery. The connection between the electric motor and the battery is the inverter. It converts the direct current of the battery into the alternating current used by the electric motor. When driving electrically, the battery supplies the electric motor with energy. The battery is recharged during braking and when driving with combustion engine. Braking action releases a lot of energy. The cooperative regenerative braking system from Bosch ensures that as much braking energy as possible is recuperated to charge the battery. The roads are quite busy today, but luckily at low speeds I can drive with electric power alone, so the vehicle consumes no fuel and emits no CO2. Oh, things are moving again. As soon as I accelerate a bit more, the hybrid control unit activates the combustion engine again. I'm now driving in fuel-saving hybrid mode, with the electric drive unit supporting the combustion engine. As soon as you pick up more speed, the combustion engine takes over again. Compared with a conventional combustion engine, hybrid drive reduces fuel consumption and CO2 output by up to 25%. In addition, we're working on solutions to improve the efficiency of the entire system still further. By combining the Bosch navigation system with the hybrid control unit, for instance, prior knowledge of the road profile can optimize the hybrid deployment of combustion engine and electric drive, further reducing CO2 output. Let's move on to the next stage of electrification, the plug-in hybrid. To make longer distance journeys with emissions-free electric drive possible, the hybrid electric vehicle is equipped with a higher performance lithium-ion battery. Before a journey, the battery can be charged directly from a main socket with a charger, hence the term plug-in hybrid. With a plug-in hybrid, you can drive in urban traffic at typically low speeds for up to 70 kilometers using electric drive alone, that is, with zero fuel consumption and emissions-free. When the vehicle is driven faster, the hybrid control unit switches the combustion engine on. The vehicle now continues on in fuel-saving hybrid mode. Both drive units are active. At high speeds, the plug-in hybrid vehicle is still driven by the combustion engine. The battery is simultaneously recharged. Compared to a conventional combustion engine, a vehicle with plug-in hybrid drive reduces fuel consumption and CO2 output by an average of 50%. Electric drive units are becoming increasingly powerful, their range sufficient to satisfy the average mobility requirements of the general public. The electric vehicle, the next step on the electrification trail, will be entirely electrically driven with no combustion engine. The electric vehicle with range extender has a small internal combustion engine on board that can charge the battery on the road if required. Let's see how this completely new drive unit is put together. The electric axle drive sits directly on the axle and contains a separate motor generator that propels the vehicle electrically in motor mode and generates electrical energy for the battery in generator mode. The inverter is the